Is Ronald Ramasan de Villarroel.
And my name is Nathaniel Serrano.
Today, we're here to talk about the fascinating world of algorithms in education. Algorithms are powerful tools that are transforming the way we teach and learn. Let's explore how algorithms are being utilized to enhance the educational experience. Before we dive into their application in education, let's quickly define what algorithms are. In simple terms, algorithms are step-by-step procedures or sets of rules designed to solve a specific problem or achieve a desired outcome. They are like recipe that guide computers in processing data and making decisions. Now, let's focus on how algorithms are revolutionizing education. Algorithms in education refers to the use of computational methods to improve teaching and learning process. They enable personalized learning experience, adapting instruction, and data-driven decision making.
What is algorithm in education? An algorithm in education is step-by-step process or a series of rules created to address certain issues or carry out particular activity in relation to teaching, learning, and educational administration in order to facilitate various educational processes. These algorithms are often implemented in computer-based system and software programs. Here is a chart that will help us understand how education algorithm process step by step. First, the teacher will provide a configuration file to put in our system. The target program will analyze the configuration file. Then, while teaching, the learner will study, or depending if the learner is answering a question, it will put as an input in our system. Then, the system will analyze the input depending on configuration file. Let's say we add another question to improve learner's schoolwork. Then, it will be used as an output as a new learning material. The uses of algorithm indication are: one is personalized learning, which providing the student with content and activities that are tailored to their individual needs and interests. Can be used in assessment, which assess the student's learning, which provides with questions that are tailored to their current level of understanding. Instructional design, which can be effective and engaging for students by using algorithms, analyze the student data, and identifying the most effective methods for each student. It also used in research, which helps to identify factors that contribute to student success and develop new educational interventions.
And now we will proceed in algorithm use in education. And we will explore two powerful algorithms used in education: natural language processing and collaborative filtering. These algorithms play a significant role in enhancing the learning experience and providing personalized recommendation to learners. Let's dive in and understand how they work. First, let's discuss natural language processing. NLP is a branch of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language. In the field of education, NLP algorithms are employed to analyze and process text-based data such as student essays, learning materials, and online discussions. NLP has a various application in education. One prominent application is automated essay grading, where NLP algorithms assess and provide feedback on student essays based on grammar, structure, coherence, and content. This helps educator save time and provide timely feedback to students.
The model we use this in natural language processing is sequence-to-sequence model, which is a deep learning architecture widely used in natural language processing, and it is particularly effective for sequential data applications such as machine translation, text summarization, and question answering. Sequence-to-sequence is the sequence that refers to sequence of words or tokens in a sentence or document. Every word and or sentences can be represent one or more token. Architecture and mathematical model of the sequence-to-sequence model is made up of two major parts: an encoder and a decoder. Both components are commonly implemented with recurrent neural network or RNN, such as long short-term memory or LSTM, or gated recurrent unit. The best case scenario for a sequence-to-sequence model with attention in the context of text summarization could be summarizing a news story that follows a clear and structured framework. For example, if the input is a news item with a well-defined introduction, major body, and conclusion, and intent summary concisely conveys the essential points and primary concepts. In this situation, the model may successfully attend to the article's main sections and provide a coherent and useful summary. Another thing to add is having a contextual text regarding of what it is, like context to a question, which provide more accurate answers. The worst case scenario is a highly technical or scientific article with extensive details and specialized language could be a worst case scenario of sequence to sequence paradigm. Text summary. When the input article contains complicated concepts, domain specific jargon, and unclear reference, the model struggles to produce an accurate and understandable summary. Furthermore, if the material lacks apparent organization or coherence, it can complicate summary and potentially result in inferior or nonsensical summaries. The flowchart of natural language processing illustrates the NLP process for determining user intent. It entails segmenting the user input and navigating to an intent table specified categories and keywords. To improve input coverage, synonym expansion is used. The process input and intent keywords are compared using cosine summary. A hybrid approach is used to determine user intent by employing cosine similarity and other calculation. Finally, determined purpose is returned as output, offering into the user's intention or category of input.
Now, let's move on to collaborative filtering. CF is an algorithm used to make personalized recommendations by analyzing the collective knowledge of a group of users. It works under the assumption that learners will similar preference and benefits from recommendation based on the experience and choices of other similar learners. CF has found extensive use in education, particularly in online learning platforms. These platforms employ CF algorithms to provide personalized recommendations to learners based on their preference, behaviors, and ratings. By analyzing large amount of data on learning activities, CF algorithm connects similar learners and suggests relevant education resources, courses, or learning paths. The CF process involves two main approaches, which is user-based CF and item-based CF. User-based CF identify learners who have demonstrated similar interest and recommends resources that these similar users have found useful or engaging. Item-based CF, on the other hand, focuses on finding similar resources based on their attributes, recommending resources that have been positively rated by learners with similar preference.
Lang. In collaborative filtering algorithm, methods used as matrix representation of user item interaction. The matrix is also known as the utility matrix or rating matrix. The rows and columns represent users and the matrix elements reflect the ratings or interaction between users and things. Because not all users have interact with all the items, the matrix may be sparse. The best case scenario for collaborative filtering can deliver reliable suggestion when user item interactions are dense, which means that most users have evaluated or interact with a large share of accessible items. For example, if a movie streaming platform has a large user base and the majority of the user have evaluated a wide range of movies, CF can create exact suggestion by identifying individuals who have similar tastes. The worst-case scenario for collaborative filtering may fail to deliver appropriate recommendation in a setting with sparse user item interactions, where just a few users have evaluated or engaged with a restrict number of objects. For example, in a new online marketplace with a tiny user base and minimal item ratings, CF may struggle to identify person or goods that are comparable enough to make reliable recommendation. The flo-
The flowchart of the collaborative filtering algorithm, and the flowchart begins with data preparation, which organizes and prepares the user item interaction data for future analysis. The correction co- co-
coefficient.
coefficients
Coefficient.
are then generated to account for factors such as user bias or item popularity, with the goal of improving recommendation accuracy. Following that, preference estimation for unknown user item situation occurs, offering an estimate of possible interest or ratings for user or things with minimal or no interaction data. The collaborative filtering method then construct the suggestion list based on the calculated correction coefficients, known user item interactions, and projected preference. Finally, the process close, bringing the recommendation generation phase to a close. Wait, in conclusion, NLP and CF are powerful algorithms in education. NLP enables the analysis and processing of natural language in educational context, offering applications such as automated essay grading and language tutoring. CF, on the other hand, facilitates personalized recommendation by connecting similar learners and leveraging their collective knowledge.
Natural language processing algorithm in education can be used in automate feedback, personalized learning, disability support, and research. These are common uses of natural language processing, not only in education but others as well, like in some news website where you have a disability support for readers who can read because they are blind. Personalized learning can be also use natural language processing because it can track student progress and uses this information to recommend additional resources and activities which make learning more personalized based on students' experience. It also can be used as providing real-time translation for students who are learning other languages, which allows students to participate in class discussion and activities without having to translate text and participate in class discussion and activities. Application that use natural language processing in education. Edmondo uses NLP to personalize learning experience for students by tracking student progress and uses this information to recommend additional resources and activities. They analyze students' schoolworks, then using that data, the NLP will recommend them resources that could improve their learning. K-12 Inc. uses NLP to grade student work, provide feedback, and identify areas of weakness, like submitting an essay. If there's a grammatical problem in their essay, it could suggest uh, grammar correction through feedback. If there's something part of the essay cannot be understand, the NLP could provide a feedback regarding to that unclear statements or paragraphs. Google Classroom uses NLP to track student progress and provide feedback. Google Classroom also uses NLP to generate personalized learning plan for each student.
And doon nagtatapos po ang aming presentation. Again, my name is Ronald Romason de Villarroel,
And my name is Nathaniel Serrano.
and thank you po.